Hi everybody, welcome back to another video on Feynman integration. First of all, I'd like to apologize for the background noise. We're having a bit of a storm here, and I'm pretty sure that microphone is picking it up. So today, what we're going to be doing is evaluating this integral right here. We have some value I being equal to the integral from 0 to infinity of 1 minus cosine of ax over x squared dx. And we're going to be using two tools today. The first one is the Leibniz rule. The second one is the fact that the integral from 0 to infinity of sine ax over x dx is equal to pi over 2 for all values of a not equal to 0. Because of course, at a equals 0, that whole thing evaluates to 0. I proved this twice on my channel, I believe. The first one was in my third video, or example number 2, and the second time I solved integral from 0 to infinity of sine x over x dx using Euler's formula in combination with the Leibniz rule to get the same thing. That was examples number 2 and 5, I believe. But anyway, we'll be using that fact today. So, like always, what we're going to do is create a function of t and go from there. So, f of t is equal to 0 to the integral from 0 to infinity of 1 minus cosine of tx over x squared dx. Now, I realize I could have just called this a function of a. That's true. I wanted to do it this way to kind of help you visualize that in here, the a here is really an arbitrary constant, because most of the time you'll see things like 1 minus cosine of 4x, 1 minus cosine of 5x, or something like that. So here a is an arbitrary constant, and here this whole thing right here is actually, it's a multivariable function integrated with respect to x to give you a function of t. So anyway, there's our function of t. We note that f of 0, evaluated at the point t equals 0 will give you 0, because you'll have 1 minus the cosine of 0, which is 1, or 1 minus 1, which is 0. The second thing to note is that f evaluated at a is going to give us our integral, what we want. So, what we want to do is use the Leibniz rule for differentiation under the integral sign to find f prime of t. That step is right here. And what you get when you do that is f prime of t being equal to the integral from 0 to infinity of sine tx over x dx. And we know from right here and 2 previous videos that that evaluates to pi over 2. Shown right there, pi over 2. Again, we're not interested in f prime of t, we want f of t. So we integrate. What you get, if you do that, is f of t being equal to pi t over 2 plus c. Because simply integrating pi over 2 with respect to t is just going to give you pi t over 2 plus c. So then we can find the value for c by plugging in the fact that f of 0 is equal to 0. With that, we get that 0 is equal to 0 plus c, or c equals 0. So now to find I, all we need to do is plug in a to our function of t, and that will give us I being equal to pi a over 2. And that's it. That's the answer. I hope you enjoyed that.